My name is Allsbrook. I'm CTO and co-founder of a software company called ClearBlade. ClearBlade, just to set the stage, we do software that helps companies that are often doing infrastructure. Things that have assets in the field, lots of important, expensive pieces of equipment that they want to use, monitor, and effectively, basically gain productivity. So we're going to talk about KPIs. Our customers today with ClearBlade are things like solar farms, so looking at the data coming off of the strings, of panels to strings, to combiners, to inverters, moving all the way up and understanding, tying that with other data sets. But ultimately, we all need to begin thinking about KPIs. I'm going to dive in, I'm going to tell as many stories as I can about real life, but I'm going to start with what are KPIs? Key performance indicators. There's a time where we're all learning these acronyms. I'm coming from the technical world, so I saw acronyms on the last slide that I don't know, so I'm going to just try to make sure I define everything. But these key performance indicators are numbers, they're ratios, they're statuses of things in our processes that let us know if we're doing a good job. I captured a few up there. I would imagine many of you are familiar with these if you're coming from the solar space or the hydrogen space and you have assets that you want to make sure are running optimally. You might be getting these KPIs. What's interesting about KPIs is they actually vary a lot more than you would think. We act like this is some like standard practice that you always follow these certain indicators to know if you're doing a good job. But they actually have to relate to the consumer. They have to look at who needs this indicator and for what reason. If we have good KPIs, we're able to take action. We're able to take action that actually changes how we run our operations. I look at KPIs that should make our equipment last longer in the field. They should help us have higher uptimes and make sure our equipment is running at higher rates and times. And it should make a better quality product, whether it's the power in the right phase power factor that matches the load, whether it's the ability to make sure that we have the right ratios of stuff coming out of the ground. All of that's important. So I look at that and I said, those should be the outcomes of good KPIs. What is a good KPI? It should be actionable. It should be something that we can automate and get easily. And if you think about that, it should be something that you can't cheat. Right? Many KPIs of things coming back from end users or coming back up to leadership are things that people are just writing down by hand. I like to actually think about KPIs in terms of not only what we want them to be, but what are bad ones. So if they cheat or you can work around them, if they cause you to focus too much on one specific area, that's a problem. Also, when we look at these, we want to make sure that we're getting things that are actionable that we can change, right? So if we think about what are bad ones, if we can't change it for around the weather, that's a problem. For uselessly making people write expiration dates down to make sure we don't have expired product, then that's a problem. So ultimately, we're looking for good KPIs that let us take action and improve our business and create higher quality. Who uses these things? In our world, and I'm an IT guy, I come from software. Guess what? Software users are never the ones that are looking at these KPIs, right? We often think that we want software and we want that language, but the reality is it's the operator. And when you talk to an operator, they'll say, I've been getting KPIs for years, and I love talking about what was the best operational connected API or KPI ever, was probably when we started launching stuff to the moon, right? We were able to connect these devices very far away and be able to get real-time data coming back over transmission over very little technology, quite frankly, right? Obviously, our phones can do a lot more than we could ever do here. Operationally, these astronauts who are the operators were able to talk to the back office sitting right here in Houston and able to get live data and get KPIs about the performance. So that's a great start. Why is it so hard to get KPIs today? I look and I'm like, I still can't get the stupid printer to work in our IT. Right? Why is it that we know how to get KPIs in an operational environment that's important, but this thing that we all use every day, maybe y'all's printer works better than mine, but this is literally my home printer. I have 7 printers. I'm trying to get one of them to work with Mac OS this and iOS this and Android that. So why is it so hard to get this data? Because this is the data that IT needs to help generate these KPIs. It's because we live in a diverse world of change. If my iOS wasn't changing, if my Android wasn't changing, if the printer standards weren't changing, we probably would have solved this. We'd still have green, white bar paper going through over reels probably, but ultimately it would work consistently. So we live in a world of change that's making it incredibly hard to get the data we need for our KPIs consistently over time. This ultimately is describing what is an IoT problem in the world today. IoT is Internet of Things, for those of you who are new to this space and come at it from different angles. Internet of Things is the new technology we're hearing. It allows us to monitor our solar farms. It allows us to get data that might have traditionally been SCADA data with a human HMI interface, a human machine interface out in the field. It allows us to take that data and bring it back to where our leadership, our executives, our back office folks are to understand what's going on. So we need to lean into that technology, but we have to overcome these challenges that we're seeing to get the data back that we need for our KPIs. In IoT, we see a lot of great stuff. If you're operating or developing a solar farm, you're probably using IoT all over the place in many ways. Often it's going to individual systems as you construct. You're seeing that data go into the performance of building out the solar farm. You're seeing the equipment that installs it, the trucks, the routing, the logistics. All of that is IoT. But putting all that data together for one entity, for one person to look at is quite the challenge. We see challenges with data velocity. These machines can make a ton of data. How much do you actually need in your back office for your executives to understand, for the schedulers of work to understand what's needed in the field? We see tremendous amounts of data that say the same thing over and over. I'm on and producing power. I'm on and producing power. Do you need to say that 7,000 times back over your cellular or satellite, wherever you need that? We see velocity challenges. And we often see data that we can't do anything with. We get lots of data, we produce business intelligence dashboards, and we look at it, and then we can't take an action. We don't know what to do. We can't tilt the panel. We can't turn off the pump. We can't alert the tank battery to the actual person that can empty or refill or repair the tank. We lack the action out of this. All of these things go back to those technical challenges of how are we going to derive KPIs that allow us to actually take action. So these are things that are challenging about IoT, but we all begin to see that IoT is possible thanks to our homes. We've got connected refrigerators and hot water heaters, so we know this is possible as we go forward. There's an interesting study that was done. IoT Analytics, they look at this holistically, look at it the same way kind of ClearBlade does. We see the monitoring of these field assets, the protocols are similar between industries, and they said, what's holding back these projects? Why aren't we more successful? I'm going to zoom in, so don't squint too hard. But ultimately, what you see here is a number of challenges people identified, and they actually have identified them over more recency versus older challenges, so it's over time change. And they call out three things that I saw as the top three, and obviously had the most. The first is missing capabilities in IT. I think I go back to the fact that we can't get printers to work, right? We always still struggle with that today. So we see people saying it wasn't that bad of a problem, but now it's a bigger problem than it was. It's now 18% of the problems. We see people really worried about cyber attacks, which is good. We live in a world where people have not taken this seriously. And we also see missing capabilities to the end user. I'm going to take a little liberty. I read the 4 pages about this bullet, what this means. To me, this means we aren't getting the KPIs to the actual user to take an action, right? We got a bunch of developers admiring the fact that they've got a big data lake, but we haven't turned it into actionable performance indicators that we work on and fix our processes. So I look at this kind of data and I say, it's actually interesting, the ones that move down were often the technical challenges of how are we going to connect this stuff up. The IoT challenge has in the past been more about what is this technology, how do I put a cellular card in, how do I move data over cellular and then get the places in the right spot and fill that data lake. We see that diminishing, and now we really see in all of these cases, we need to better serve the user. That's a passion with ClearBlades. We want to serve the operator. I work incredibly hard to make sure our teams are thinking not about the developer who wants to stream data. That's important, that's a necessity. We work to make sure you're serving the operator. The person in the field needs enough data, needs the right indicators to know when they drive a truck out to fix something because power production is down, they need to know what's wrong before they leave, before they drive out there. They need to know have the right part. They need to have all of that in their truck and ready to go, understanding what's happening. This is what we're after. This is what we're trying to do with our KPIs, is really solve this bottom challenge. And this represents a tremendous amount of maturity in all our industries because we now understand that we are missing the actual value of all of this technology underneath. Right? I think we're all familiar with industries that get really excited about technology and forget to solve problems. I think we're looking, and we may have a lot of technologies like AI that we've yet to figure out how do we solve problems for the end user. I'll mention just as background, I think the fact that we've diminished and we're beginning to see less challenges, and now we're thinking about how do we get security in here, how do we get this data back to the right place, how do we put it in the operator format. I put up a simple architecture slide. I promise it's the only technology box slide we've got on the deck. So we won't talk about it anymore after this, but it's pretty simple. If you go to some hyperscalers, there may be more boxes because they break it up much more, but really we see, in the case of a solar farm, solar array, we see a left to right trying to get from the thing to the end user looking at their phone, looking at their big screen. But it's pretty simple. It's the SCADA system that's probably already been there. It probably talks a protocol like Modbus or OPC UA. These are just protocols for how data would get off of them. They're legacy, so to speak. We see that we want to put some computers out there. We generally call that a gateway computer that sits in the field. What's new? Maybe we've got new things to monitor. Maybe we've put in a LoRa network to look at tank levels or lubricant levels or where trucks might be. Maybe we've put in a weather station, net new data. We see a need in that gateway to figure out how to get the data from all the different places. We call that edge in the industry. So we have edge processing, and then we need to get it to where our IT can help us create KPIs. We call that the server side, maybe you call it the cloud side. It's the IoT platform that's going to get that data. And yet again, we see similar behaviors. We see legacy information. We see the database that we've always been using over the years. We often see streaming systems because there's going to be 18 different departments that want the data. We have to serve those. We see new opportunities to do AI inferencing. Lots of companies build specific models to understand exactly when panel life needs to be changed, or exactly when we need to perform certain maintenance routines, or exactly how to respond to weather changes. We would do that AI inferencing. That's net new that's coming in and all needs to work with the system. But it's all to get to that right-hand side where we're going to produce a KPI, some sort of indicator, some sort of value prop to the user who's logged in. That application allows them to then make changes. I think this represents, and again, I put in ClearBlade because they play in the space, but ultimately everybody is doing this edge, this IoT server, and integrating with the ecosystem around it. How do we then turn what is a lot of nerdy things? I talk protocols. I wasn't supposed to say any protocols. I talked to them. But how do we turn all of this big data into something that's operational? What we do is we try to forget that there's technology underneath and turn everything back into how we run our businesses. We call it intelligent assets. Industry generally calls it digital twins. Digital twin is just digital representation of what we might have in the field. A solar farm is comprised of inverters that connect to mini combiner boxes, that connect to strings, that connect to panels, right? You can break all of this down to have understanding, and each one of those has sets of attributes. Power in certain phases, what's the current, what's the voltage going through these things. All of that information comes back up and is represented in a digital twin. For good KPIs, you can't just do digital twins, you have to have them connected, especially in this industry. You need this data hydrating constantly So while we've forgotten about the technology, we have to use this technology to constantly get the new data, bring it up into the different environments. And when we look at this conference, just talking about the infrastructure in just a few examples, whether it's looking at fracking water, whether it's looking at proppants, whether it's looking at emulsifiers, and going into tank batteries and looking at tank battery storage and how all of that's done, this application, this ability to create digital twins, brings it back to the operator, lets the operator do the calculations associated with the KPIs they need. We see it not only in, say, solar, we see it in things like EV and EV charging and tracking of the EV vehicles. We do that today. The same application supports it because of the digital twin setup. We see it across things like the buildings and consumption. Almost everybody in the developer world not only has a need to operate, but they also have the need to construct. So we have the vehicles, the logistics, all of that information is coming across to us. And that's really what we're working to achieve with our connected digital twins for our operators. It lets them see their KPIs. I'll show you some quick examples. Again, I started off by saying KPIs were not the same for everyone. There are some users who are the operator out in the field. These operators need very specific views. I actually put them on mobile phones because most of the folks that are actually looking for KPIs to do action aren't sitting behind a computer at a desk all day. They're probably in a truck sitting, but they're moving around trying to look at things. Sometimes they want macro views. You can see there on the left-hand side, they've got dashboards that look like the SCADA HMI view where they're looking at fans on and off, getting quick understanding across all their assets at a dashboard level. Sometimes they're driving all the way in, looking at indicators of exactly what's happening at a very low level. And then sometimes they're stepping back and not even monitoring anything, simply waiting for the digital twin to have certain states to satisfy certain rules, and then they see the event that drives an action. All of this is important about having a connected digital twin that serves operators. Now what's cool is this data underneath that lets me go to work every day and solve my operator job also hydrates up. It comes up, it gives me macro views. In factories, we want to have maybe a line, maybe we want to have a machine, but at some point we want to know overall production across this facility versus other facilities. We want that executive view, so to speak. The same data set moves up. As we move up, the digital twin gets to be a bigger asset. We see addition of all of the production of units line by line come through. We see all of the generated power summed up across the month so we know what's been created. And we also end up with this executive view of KPIs. In the case of the solar farm, we drive back to that very first list we showed. What is the power factor and are we matching it? What is the uptime? How much maintenance have we done in this field? We've tied in that other data lake, the service worker orders. All of that information is put back together, and we provide what is also the KPIs derived from the bottom up of automated gathered data so that we can actually take action and understand what's going on. I'll give a quick anecdote as I wrap up. This is a continual process. We see lots of systems that do that initial SCADA, right? We unlock the SCADA, we get it to over the cloud, we look at it in a dashboard for business intelligence. We add a button to automatically do things so I don't have to roll a truck and get out in the field. We've added command and control. Now we see things like AI, and we see really where we can actually train on moving or using third-party data for maybe solar or radiance or whatever's coming through. We also see that we now can predict actual values and create behaviors and rules that our operators understand without ever knowing data science, without ever knowing AI. They can just see predicted, different than actual by 10%, and we take an action. This is the world we live in. I hope you have a chance to come by and visit us. We're at booth 111, and thank you for the time.